There is a sound coming from a place with no air, no wind, no atmosphere, no medium that should be able to carry a sound at all. And yet, for over a decade, a machine drifting through the dark has been recording it anyway. Not static, not silence. A tone, faint, structured, and constant, rising and falling like something almost deliberate. Scientists didn't expect to hear anything out there. This is the real story of what Voyager 1 has been listening to. The discovery moment. On September 5, 2013, NASA's Jet Propulsion Laboratory in Pasadena confirmed something extraordinary. Voyager 1 had left the heliosphere, the vast bubble of solar wind that surrounds our sun, and entered interstellar space. It was the first human-made object to do so, but the confirmation didn't come from a camera. Voyager's cameras had been dark since 1990. It came from an instrument almost nobody outside JPL had ever heard of, the plasma wave subsystem, a pair of 10-meter antennas designed to detect vibrations in charged particles too faint for any other instrument to register. In April and May of 2013, that instrument picked up something strange: oscillations in the plasma around the spacecraft, caused by a burst of solar activity that had taken over a year to reach it. Those oscillations had a frequency, and frequency, when translated into sound, becomes something almost impossible to ignore. It became a tone. Not one Voyager was built to find, not one anyone was listening for. But once JPL engineers converted the data, they realized the spacecraft hadn't picked up a single burst and gone quiet again. It kept humming. The scale of the silence. It was sitting in. To understand why that tone mattered, you have to understand where it was coming from. Voyager 1 launched September 5, 1977. By 2013, it was over 11 billion miles from Earth, a distance so vast that a radio signal traveling at the speed of light needed more than 17 hours to make the trip. Interstellar space is not empty, but it is close to it, roughly 1 particle per cubic centimeter compared to a fraction of that inside our own solar system's outer reaches. And yet, even in that emptiness, particles still carry oscillations, still vibrate, still, in a very real sense, sing. Nobody expected a functioning instrument, built in the 1970s with technology older than the personal computer, to still be sensitive enough to catch it. Nobody expected the song to still be there years after the event that triggered it should have faded. And nobody, least of all the small team of plasma physicists monitoring the data, expected it to keep happening again. Stacking the evidence, year by year. The first detection, in 2013, was explained fairly quickly. A coronal mass ejection from the sun, a wave of charged particles thrown outward during solar activity, had rippled outward for more than a year, crossed 11 billion miles, and rattled the thin plasma around Voyager 1 like a struck bell. That should have been the end of the story. A one-time event, a single note, then silence again. Then, in 2014, it happened again. A second wave, this time weaker, arrived and set off another oscillation, proof the first event hadn't been a fluke, and that Voyager's instruments really were sensitive enough to catch these vibrations from a source 93 million miles away, filtered through more than a light day of empty space. By 2017, the plasma wave team, led by University of Iowa physicist Don Gurnett, the scientist who had designed the original instrument back in the 1970s, noticed something even stranger buried in years of accumulated data. The plasma wasn't just ringing after big solar events, it was humming continuously at a low, steady level even when nothing dramatic had happened at all, a faint, persistent tone. Present in the background almost all the time, structured enough that it could be measured, tracked, and, remarkably, turned into an audible sound. In 2021, the finding was formally published in the journal Nature Astronomy. Voyager 1's plasma wave instrument had detected what researchers called a persistent narrowband emission, essentially a continuous hum in the interstellar medium itself, not triggered by any single event, but simply present, like background noise that had always been there and had simply never had a microphone close enough to catch it. By 2024, the team had confirmed the hum was still there, 11 years after the first detection, in a region of space no other instrument had ever measured directly, still ringing, still steady, still being recorded by a spacecraft older than most of the engineers reading its data. The bigger theory. It was around this point that one interpretation of the hum began to move beyond the plasma physics community. Some researchers, echoing ideas Carl Sagan himself once floated about the broader philosophical implications of Voyager's journey, proposed that this continuous tone effectively functioned as a kind of ambient signature of the galaxy itself, a background hum in the material that fills the space between stars, something that had likely been there for billions of years, utterly indifferent to whether anything was ever built that could hear it. Taken further, a handful of commentators suggested something more provocative, that if interstellar plasma could produce a detectable structured signal purely from natural physical processes, then any claim of an artificial or intelligent signal from deep space would need to be measured against a far noisier, far stranger natural baseline than anyone had previously assumed, that the universe, it turned out, was not as quiet as SETI researchers had spent decades imagining. It's a striking idea. Compelling, too. Compelling enough that mainstream plasma physicists moved quickly to rein it in. I'm pulling it back to the evidence. The scientists who actually work with Voyager's data are careful, almost insistent, about what this hum is and is not. It is not a signal in the sense of a message. It carries no encoded information, no pattern beyond what basic plasma physics would predict. It is the natural byproduct of thermal excitation in interstellar plasma, electrons vibrating at a frequency determined by the density of the medium they sit in, a phenomenon plasma physicists had modeled mathematically decades before Voyager ever detected it directly. What made the discovery remarkable wasn't the existence of the hum. Physics predicted something like it should exist. What made it remarkable was that a 50-year-old spacecraft, built before the term interstellar medium was even common in public science writing, turned out to be sensitive enough to actually measure it, turning a theoretical prediction into 11 years of continuous, real, recorded data. Gurnett, before his death in 2022, described the finding not as mysterious, but as an entirely new way of studying the density and structure of the material between stars, a tool, not an anomaly. The excitement was never really about the hum being unexplainable. It was about the fact that for the first time, humanity had a working microphone in interstellar space at all. What the instrument is doing right now today, the plasma wave subsystem remains one of the few instruments still active aboard Voyager 1, alongside its magnetometer and cosmic ray detectors. Its power source, a plutonium generator installed before the spacecraft launched, loses roughly 4 watts of output every year, forcing NASA engineers to power down instruments one at a time to stretch the mission as long as physically possible. The plasma wave instrument is expected to remain functional into the early 2030s, continuing to log the density and vibration of the plasma Voyager 1 passes through as it moves outward at roughly 38,000 miles per hour. Each new reading adds to the longest continuous record of interstellar plasma ever collected by a single instrument. One small antenna pair, unchanged in design since the Nixon administration, still doing exactly what it was built to do, 4 decades past the point anyone expected it to still be listening. The question left behind. There is something unsettling about a sound that was never meant for anyone. No civilization broadcasting it, no message encoded inside it, just matter, doing what matter does when nothing is there to disturb it, vibrating quietly in the vacuum, indifferent to whether anything was ever built that could translate that vibration into something a human ear could recognize as a tone. Voyager 1 didn't go looking for this. It found it by accident, sitting in the data for years before anyone noticed the pattern. Which raises an uncomfortable possibility. If a 50-year-old instrument, never designed for this purpose, could stumble onto something this fundamental simply by being far enough away and listening long enough, what else might already be sitting in that same stream of data, waiting for someone to notice it? Voyager's plasma wave instrument has, at most, a few more years left before it goes silent for good. If you want to know what happens to the rest of the spacecraft once that silence finally arrives, that's a story for next time.